Suppose that the number of texts sent during a typical day by a randomly selected high school student follows a right-skewed distribution with a mean of 15 and a standard deviation of 32. Assuming that students at your school are typical texters, how likely is it that a random sample of 40 students will have sent more than a total of 1,000 texts in the last 24 hours? So we have here a population of high school students in general. So our population, all high school students. We found that they text with a mean of 15 and a standard deviation of 32 texts per day. Now we want to know how likely is it that a random sample of 40 students from your school will have sent more than 1,000 texts. So in our sample here, we have a sample of 40 students. So we're going to say n is 40. Now we also want to find out what our mean of our sample is. Well, if 40 students send a total of 1,000 texts, then our mean would be the total number of texts divided by the total number of students. So the average number of texts is 25 texts per day per student. We want to know if that's unusual. So to find out if that's unusual, we want to know how much an average of 25 texts per day varies from the typical average of 15 texts per day if sigma is 32. So this means we need to look at the distribution of sample means. So our sampling distribution of x bar must have a mean of 15 and a standard deviation of 32 divided by the square root of 40, which happens to be 5.059, if the conditions are met. So we have a random sample, so we know that that's good. We need to know that 40 is less than 10% of the students. Well, since our population of students is all high school students, I would think that 40 would be less than 10% of all the students. So that's a check. And if we're only doing it from our school, we could even say probably that 40 is about less than 10% of our school. But actually we're drawing from a population of all high school students. Secondly, is our sample size large enough that we know that the distribution of x bar is going to be approximately normal, because this original population is right skewed. Okay, so we have a right skewed distribution, so we need to check that condition. So we know that 40 is greater than or equal to 30, so n is big enough to use the central limit theorem. Okay, so that means actually, rather than saying just to use the n is big enough that the distribution of x bar is approximately normal. Okay, so we know that we can use the normal model to answer this question. So we have a normal model here with a mean of 15, a standard deviation of 5.059, and we want to know how likely is it to get a sample sample mean, because remember this is just a distribution of means, that's greater than 25. So we're wanting to know what's the probability that x bar is greater than 25 in this particular distribution. So we go to our normal CDF to check this out. Normal CDF would be 25, infinity, 15, 5.059, and we get a probability of 0.024. So not very likely. How likely is it? Not very likely. It is not likely that 40 typical texters will send 1,000 texts in one day, because there is only about a 2.4% probability of getting a sample like this from the given population. And later, as we talk more about this, we'll decide if that's not likely to happen, then either one of two things is happened. Either our original population information is not correct, or our sample is not a group of typical texters, that maybe from this high school students tend to text more. So that's how we would interpret that.